Welcome back, guys. This is part 2. Well, I'm actually calling it part 1 because we're still part of just getting the bot to work. But I've got this notebook, which you can see in the link below. And so I'll quickly run through what we're going to do just to give context, and then I'm going to go through step by step. So the idea of this tutorial is to record the random games. So if we go back to the bot quickly, we can see that we've got two bots playing randomly, and we want to record what they're doing, and then we can work out what to do with that to start making an AI to start playing, better than random. So I'll go back to the tutorial here. So we're going to make 2 changes. The first thing we're going to do is we're going to set up a file name so we can save the data every time a new game starts. And then we're going to change the alright. So I'm just looking at it first I was confused what I was doing. So I wrote this about 2 days ago. So this is just looking at the function, and this is what we're going to do to modify the function. Alright, makes much more sense. So the idea is we want to store the games, and then we do want to make sure that the bot always chooses a valid column, because I noticed that sometimes it will just stop working by putting a token in, like say the 6th column that's full, and it will kill the game early, but kind of isn't great for the training data. So I just thought I'd just make a way to choose a valid column that will just help a little bit. And so these are the changes that we're going to make, but I'll go through this line by line. And then there's a complete code. So at the bottom of the notebook, you can just copy that into your bot, and then it'll just work. So, all right, let's get started. So I'm going to move this to my second screen. And if you have a second screen, I'd recommend having this on the right-hand side as well. I like to use PyCharm, which is a pretty cool, I don't even know, I think it's called IDE for Python, but you can use whatever you like. I just find this nice and, easy to read, easy to use, sorry. And then I've also got an idle, so this is good for sort of just reading and editing. So I'll keep this on my other screen as well. So the first thing we're going to do is grab the original bot, which is going to be not in here, it's going to be in, for me, it's going to be in my GitHub cloned. Copy this. So no, I don't want to, so this, what I would do with idle is open with idle, copy, paste. So we now have, where's my camera? This is the starter bot that was provided and is playing random games. So we've got a nice to-do here, implementing the bot logic. So the first thing that we want to do is work out a way to save the games. So when the bot starts, it calls this state class. And again, if you don't know what classes are or objects are, don't worry too much. Essentially, it just creates a state that we can call on every time. So I'm going to go self.name equals. So I'm going to save it in a new folder, which I haven't made yet, called saved games. So I should do that now. So I'm going to go back into the cloned folder, make a new folder called saved games, and every time a game gets saved, it'll go in there. So we've got that folder, but we need a name that's unique every time, and these games that rack up pretty quickly. So to make sure we have a unique name every time. It's not great, but it works for now. So I'm going to do a string, and before I do this, I need to import a new module, time. So I'm going to go string of time.time. So that's giving us the correct time. That's giving us the time of right now, and then we need a plus dot npy, because we're going to save it as a Numpy array. And this time to time could be a decimal, so what I'm going to do is just make it an integer. Put the integer here. So the file is going to be saved in saved games, and it's going to be called the current time.numpy array. So at least that's always unique. So if we scroll down to the make move area, at the moment it's just making a random choice through a random column. So we want to do two things. The first thing I want to do is save the game, and two, we want to make sure we have a unique column. So to save the game, I know the best way to do this is probably store the game in the, I guess like in an object that gets called, but just for simplicity, I thought I'd just save it after every move and then reload it before we make a next move. So I know it's probably not ideal, but it works, and I'm pretty new to this, so if you have any constructive criticism of efficiency, please let me know. So I'm going to go if state.round equals 0, then the current board equals, now, numpy, so np, so that's numpy, we haven't got that yet, so we need to go up here and import numpy as np. Numpy.zeros, now we need to do double brackets, 30, so we're expecting up to 30 rounds. 6 is the height of the board, and 7 is the width of the board. So if we do a quick check of what, now I can't, because of the way this is working, I can't print any results. Later on I'll print as we go so you can see, but at the moment you're just going to have to trust that this works. And if it's not around 0, so if else, the current board equals numpy.load state dot name. So that's that name we defined before. All right, now the field state is given to us already, so we can make an array of the state.field.field state. This is a list, and then we make a numpy array of the list, and it has shape. It has a shape where each dimension, I guess, is a different row. It's hard for me to explain this because in the bot you don't really get any, you can't like print out results. So it took me a little while to figure out how this works. So I'm just going to go through it. We'll make sure it works, and then going forwards, when I can print out results, we'll go through and make it a bit easier to understand. Now, one thing that I've noticed that the starter bot doesn't do is it doesn't increment the round every time. So I think what we need to do is up here in the action. Before this happens, we need to go state.round plus equals 1. I think that was just a mistake because, yeah, that should be incremented. And yeah, so that's what I did. Cool. So like I said, this field state comes as a numpy array with each row as a separate array. So we're going to go for row in range 6, because there's 6 rows. The yellow index equals numpy.where field state of the row equals 1. And so we've been given that through the document, so I won't go through that. But if this field state is 1 when yellow, where it's yellow, and then red comes in as a 0. So the red index equals numpy.where. See, I like PyCharm because as soon as you start typing, it kind of works out what you want to write. So I can just press enter. Row equals 0, and there's strings, which is kind of weird, but I guess it's just the way they do it. It's efficient. And so now we've got this current board So what I want to do is the current board of state.round, so that's, we're indexing to the current round. So say we're trying to store 30 rounds. Say we're on the 10th round, it's going to be we're going to access the 10th, this here would be 10, the 10th board of this Numpy array of the row that we're accessing, and then the yellow indexes equals a 1. So we're going to set, because this current board is all zeros, we're going to set all of the yellow indexes to 1, and then the current board of state.round of the rows of the red indexes is going to equal -1. So we're going to have 1 where it's yellow, -1 where it's red, and then zeros where it's blank. So that's all. So now the current board's going to be updated. It hasn't been saved yet, but I'll do that at the very end. Actually, I'll just do that here. So we're going to go numpy.save state.name, so that's what it's going to be name saved as, and then what we are saving is the current board. So every time we make a move, before we make the move, we're going to save the record. And so when it's a brand new round, we're going to make a new one, and if it's say the 10th round, we're going to load the old board, update it, and then resave it. So that's now saving games, but what I should do is make sure we've got a unique column sorted, a unique column selected. So valid index equals numpy.where current board of state.round, so that's getting to the correct record, where it equals 0. So this is going to return, say, all the values that it's going to return all indexes, all indexes that are 0. We're then going to shuffle them. numpy.random.shuffle valid index. Now we don't have to make this equal to anything, so you just call it, and it will shuffle this. And then the random column equals the valid index of 0. So we want the top row, basically. Yeah, okay. So the valid index comes in, so we basically get, this is the current board, where it equals 0, and then we're grabbing the top array, because it's going to be like 6 arrays. Then we shuffle it, then we grab the random column. So this is already shuffled, and then we're grabbing the very first index. So say we had, well, at this point here, valid index might equal 3, 4, 5, 6, or something like that. That actually happens, say, here. And then once we shuffle it, it's going to be 4, 3, 6, 5, something like that. And then we're grabbing the first index, we're grabbing the 4, so we've shuffled it. So I'll just delete that. And then we're going to return that random column. So I'm going to copy all of this code and then put it back into, I'll make a new file actually. So this is the GitHub cloned. We're going to just copy that and call this bot v1. Open that with idle, save that. Then we go into our game, file settings, and it's not going to be main, it's going to be bot v1.py, copy, paste, so both are playing, save, run match. Let's see if it works. We have some error. So to check the errors, you can click on this thing here, no such file or directory. Let's have a look. Now if I've got errors, I might pause the video and figure out what's happened and then come back to it. But we'll see how quickly we can fix this. numpy.save, current board. Okay, I'm back. I fixed the error and I have no idea why it is an error, but it's in this action part where we have to go move equals make move state and then return the move. And for some reason that seems to work. So if anybody knows why that is, please do tell me because I have no idea. So I'm going to save that, copy all of this now, open up our bot1.py, save, and you can see that we've got time numpy, so it's the one we've just made. And so if I bring back this here, settings, bot1, save, run match, now it's working. And you can see that it's playing. Now I'll just make sure that it's going to be, the valid columns thing doesn't pop up very often, but I do know that code works. If it doesn't, please let me know and I'll try and figure out why, but it does work in the past. So obviously yellow should have played here if it was a smart bot. So the idea is that it would hopefully make an AI that would do that. And then now that this game, well, this is a recording, but it's already been completed. If I close out of that bot, and then open this GitHub, you can see that we've got a file here, which is the time, and I think it's milliseconds in some date ages ago. And if we play, say, 10 games, we can run a batch. So if we go 10, run, it'll run. Cancel. I have killed it. Interesting. There's a bug. That's all right. I'll go back into our command prompt. Open it up again, 4 in a row. Let's play the game. If we now play 10, and then play, you should play 2, 3, 4 games. And then if we open up here, you can see that the games are recording one by one. So let me make sure that's everything I wanted to say about that. It is. So we currently have a way to play random games and we have a way to record them. So the next thing we're going to do is work out what we can do with that data. So that'll be part 2. All right, see you later.